Another type of algebra limit that we run into is one where we have to find a common denominator. Again, note that if you plug in 3 here, you get 1 over 3 plus 1, which is 1/4. So 1/4 minus 1/4 is 0 on top. 3 minus 3 is 0 on bottom. Oh, 0 over 0, that's going to be a whole in this function. Now again, this is a pretty crazy function, and we should be asking ourselves, what could this limit possibly be representing? Because if we're taking a fraction minus a fraction, all in a fraction, it must be representing something pretty important in calculus, and it does. But right now, we just need to make sure we have the algebra set before we start talking about the calculus. So again, if there's a whole here, we must be able to rewrite something up here so we get an x minus 3 that will cancel with an x minus 3 down here. So the method we know is to find a common denominator. So what we do is we say, all right, to find a common denominator, this has an x plus 1, but it's missing a 4. So we have to multiply by 4 divided by 4. So we get 4 over 4 times x plus 1 minus. Okay, what is this one missing? Well, it's missing an x plus 1. So we multiply by x plus 1 over x plus 1. So we get x plus 1 divided by 4 times x plus 1. And this is all still divided by x minus 3. Okay, now an important question is, why did we have to multiply by 4 over 4 and x plus 1 over x plus 1? Well, again, we don't want to change this function at all. So if we multiply by something, we have to multiply it by on top and bottom. So we're really just multiplying by 1, right? We're multiplying by 1. That's not going to change these numbers at all. They're the same numbers as before, just written in a different form. So now continuing to simplify, the most common error is to not distribute this negative to both pieces. All right, that's going to totally mess us up if we don't do that. So we really have to be careful. So when we combine these, we get 4, and then we have 4 minus x, okay, minus 1. That's still divided by our common denominator of 4. Oh god, my pen just broke. One sec. Okay, I'm in a full-on crisis mode because I have to write with my finger now, which is going to be a lot harder. My handwriting's bad enough as it is, but we're just going to go for it. So we have 4 times x plus 1 still, and then below that we have x minus 3. Okay, so again, we're looking for another x minus 3 in the numerator so that we can cancel and hopefully plug in 3. So we're almost there. What we have right now is we have 4 minus x minus 1, which is going to simplify to negative x. Combining 4 and negative 1, we get positive 3. Negative x plus 3. That's divided by our common denominator still. And then that's divided by x minus 3. Okay, so we're almost there, right? Because negative x plus 3 is almost x minus 3. All we have to do is, we talked about in class how he's in a disguise. We have to rip his negative mustache off, and we see that he was x minus 3 all along, just hiding behind a negative. Okay, 4x plus 1 divided by x minus 3. Okay, so, oh my gosh, such heavy algebra, but we're almost there. So now we have a sandwich. We can cancel this. We can cancel x minus 3 with the x minus 3 way down here. If you want an explanation for that, we can talk about the copy switch flip justification for why those can cancel. But basically, once those cancel, we can say now this is written as there's a negative 1 left on top, because when we cancel this x minus 3 and this x minus 3, negative 1's left over, and then we divide that by 4 times x plus 1. All right, so don't forget what our initial mission was here. We wanted to plug in 3, but we couldn't because we got a hole. Now we canceled the factors causing the hole, so now we can plug that 3 into what we have left over. So if we plug in 3, we get negative 1 over 4 times 4. Final answer, negative 1 over 16. So the y value of this hole, as we go to x equals 3, as we approach 3, it's going to approach an output of negative 1/16, where it will be a hole.